Hey, hello, hello. Zach, congrats on the first. Been loving seeing all the multivariable calc that's been happening on your stream recently. Hey, JGOXT. How about? If that's how am I'm doing good. Good afternoon to you too. I hope you're doing well. Okay, good. I think we're set to go. Just making sure I got all my things in order. Okay, yeah. So I think I'm gonna start off with some linear algebra. Because next week we're starting on complex analysis, so let's try and get this little bit of linear algebra out of the way if we can. So it's about linear transformations and changes of basis. Uh, and I've learned this before, but it's been a minute, so I want to relearn it. Is the music? The music seems like it's at an okay level. It's also just a loud song. I'm gonna turn it down just a smidge. Yeah, it's good. Like I had multivariable calculus is awesome, and I wish I had a better foundation for it. I can execute the problems, but I don't feel like I actually understand it. Um, hey, $10. I did finally watch that special relativity video last night. It does get kind of crazy. I feel like I don't quite understand the point they were making with the very last clip with why the train has to fall down the gap or that like the part I feel like I don't quite understand what they were trying to say with that, but it definitely does it definitely is a like kind of crazy. Um, yeah, so I think there's a few different ways of approaching a problem like this. We could think about we could get four equations and four unknowns out of this, which would probably be a pain, but possible. But I think there's a more direct way of getting to the equations that our heart desire. Also, hey, yeah, like I know it's a trick. This I think the matrix is just going to be that vector and that vector, to be honest. But I'm trying to remember like actually why, or I want to actually like justify it. Six chapters of the Hello Well text on special relativity, but there's short chapters. Oh, it sounds kind of like Morin's like Blue Mechanics book then, in that sense. The song kind of sucks. Whoever made it should feel bad. I'm skipping it. I don't know how's that like mean about it. Um, this is more easier way than the mind. Okay. I should really read extra stuff on special relativity. I'm just kind of like I feel like I've spent my brain power down already with just the Hartle book and then also going through the complex analysis stuff. Some artist's heart is breaking right now. Yeah. I'm sure for me that song is watching the stream right now. I think I should also just be able to logic my way around this. but I also can't. So, um, oh wait, yeah, I should just do this multiplication because from the first equation we can immediately get that a equals 2 and c equals 5, don't we? Okay, yeah, so it is just going to be these two vectors put in a matrix. Also, why do they start from matrix B and not matrix A? Be lurking, move some junk around at work. Okay. Well, good luck moving around that junk in that trunk. See you soon. Okay, so now I want to invert this transform, which is... I'm sure we could take the inverse of this matrix. But... I'd like to do it the difficult way. That's more general. I mean, maybe we'll still figure this matrix out by guess and check, rather than doing every painstaking algebra step. So, should we do it that way though? I don't know. Math here went easy. Nice. Developer, glad to hear it. Destroyed it. You love to hear it. Yeah, Mert. I wish there was a better way than this. Or I hope there's a better way than this, but this way it definitely always works. Even then it's just, it's not the hardest version of a problem where we can make it two sets of two equations each. And Excel benched all the topics. Oh no. Hey, Central. It's good playing with you. Sorry, dragged you down and broke your streak of getting into the bunker. But that's just, what I do. Um... Well, how do we think about this in the change of base, in like the base vector sense? Like, it would a linear combination of 2, 5, and 1, 3 go into 1, 0, and then a different linear combination go into 0 and 1. But would that give us the matrix though? Maybe it doesn't. Maybe we do have to do it this way. If I multiply that through by 2, subtract that one. I think B is -1. Which means A is 3. Yeah, that tracks so far. multiply that through by 2, do this minus that. -1 equals -1. Negative d equals -1. So d is just 1, which means c is a fraction. -5/2. No, that doesn't make sense. What? Did I make an oopsie? 2c plus 5d equals 0. 2c plus 6d is 1. Minus d is -1. D is 1. But from here, I get c is -2. From here, I get d is -5/2. So what gives? Did I set this up wrong? Yeah, I've gotten the same as you for A and B mer. It's just my issues with C, I guess. Why am I getting... Hey, Raton. Yeah, we can do that. Now, the best way to do problems like that is to know that sign... is to use the series for a sign, and then think about the x squared later. So sine has two common representations as a power series. We can choose either one we want. If you're given a specific one in your class, I would use that one. These are equally valid. I guess we'll start... I'm going to use the second one because it starts from 0, and I like starting from 0. Yeah, Mert, right? Okay. And so we're going to use this definition here. So Everton's, hello. We're mathing. Hope you're doing well. So let's apply the definition for sine of x as a series. The x squared stays out front. Now we get sigma n equals 0 to infinity, -1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. And now this x squared can get multiplied inside of the summation. So I'm going to bring it all the way into the x to the 2n plus 1 there. So that's x squared, that's x to 2n plus 1. The exponents add when you multiply it. So it'll be 2n, x to the 2n plus 3 over 2n plus 1 factorial. And that's all you really have to do. Try doing calculus in 30 minutes? Well, good luck. You can get the intuition for it in 30 minutes, for sure, in some of the basic calculations. So yeah, Berton, let me know if you have any question about that, but That's how I would do that. Very, very basic understanding. Fair enough. Got to start somewhere. Thank you for the question. 25 to 10, 13 to 01. This matrix is invertible, right? These are independent rows and columns. What is the inverse of B? I'm gonna break down and find it. The determinant is 1. So you swap those two, negate those two. Well, this is all sorts of wrong. Well, I don't know, you can use those. You use them all you want. Evidently, I don't know how to solve a system of two equations with two unknowns. Oh my god. I multiplied that equation 3 by 2, but I forgot to multiply the 1. Bruh. Minus d is minus 2. D is 2. Checking work for linear algebra is it's the worst. That means C is minus 5. Okay, there we go. And C is indeed the inverse of B. Bruh. So why does no matrix transform 2, 6 to 1, 0 and 1, 3 to 0, 1? That's because 1, 2, 6 is a scalar multiple of 1, 3. They're going to have to map to the same thing, potentially with a different scaling. Well, almost certainly with a different scaling, but this is my exam problems entire of my life. I'm automatically made a mistake. 2, 6 is a scalar multiple of 1, 3. So it should map to a scalar multiple of whatever 1, 3 maps to. Or vice versa. You know what else is the worst? The sausage you soak in beer and cook on the grill? That's true. You might even say it's the bratwurst. Oh, yeah, Mer. I guess we could have done it. We could have actually gone through with this approach here, too. And we get a system of equations with no solution. The next question is related. Actually, let's keep linear algebra together. And we'll shove Maclaurin series. Should we delete Maclaurin series? We don't need this again, right? We'll delete it. Hope you're doing well today, Jed. Okay, so I think based off our work from 14, we can just take RT and SU as our columns. Because it will be the exact same math. Also, why is it not RSTU? I guess so in the matrix we get RSTU. I assume for part B, the quick thing is to invert M. Oh, yeah. There probably isn't a better way. Oh, we get rust! Haha. Oh, we could spell out something funny. Well, I don't know. I'm just thinking matrices with like curse words in them. Take the inverse of this matrix. Jasper, you're like Schrodinger's cat, always lurking and not lurking. I think you're Schrodinger's chihuahua. M must be, well, okay. Oh, they use different letters? Bruh. I don't even get to spell out rust then. So it would be C, A minus B minus D, A, B minus B, C. Cats are far scarier. I guess so, yeah. Cats will like plot a lot more. A chihuahua, you can always just like kick it and you're safe, but a cat is gonna plot and try and sneak up on you. Oh, thank you, Jed. I don't know the alphabet. Wait, I'm still wrong. I'm wrong for multiple reasons. There we go. Letters are confusing. Don does math, not letters. Yep. Wait, am I still okay? Yeah, no, I think I'm good now. AD minus BC can't be 0. Now, I didn't bring up the answer key in advance, but I do want to bring up the answer key and see if they did this with a different method. I would be interested to see that. Wait. Oh, they're asking... Impossible. Fine. That's when it's impossible. It's technically correct. The best kind of correct. This is chapter 8. 8.2, number 15. Wait. Oh, this is the 8.1. There we go. I was wondering why that didn't look like our problem. Oh, they don't say the method. Maybe they say it in an example. Wait, how am I wrong? I haven't even said anything. Your finger slipped? Yeah, sure, Jet. Oh, you know what? If it is non-invertible, I bet you could... Well, no, it doesn't have to be a projection. But a projection matrix would be non-invertible. Should give you that buzz because she'd only be wrong once every 30 seconds. That's very arrogant of me to put a 30-second cooldown on that. I ever worked on cryptography. In a way, yes. Um, there, there was a time in my life where I was going for a master's in software engineering, and I learned a little bit about cryptography through that. Not very mathematical though. Uh, During my undergrad, I did a discrete math class where we talked a little bit about it too, but it's very surface level. Side channel attacks? I never heard of those. CS ERC? I don't know, but my sense of computer science is I think the concepts are amazing, but when it comes to actually like accomplishing anything, it gets very tedious. Some type of software attacks can be seen as side channel attacks. Side channel attack. Go away. I don't want your dumb cookies. Huh. It has chemistry, so you have to get out of your basement, not like regular computer science. uh. That's kind of interesting. You're trying to get information from the like while the computer is doing the cryptographic computations. Dude, you gotta be smart to figure this shit out. What the hell? Well, clearly, but trying to prepare a presentation on zero knowledge proofs for our blockchain club for next semester. Implementation attacks are kind of crazy. Yeah, like this is kind of insane if you can pull this off. Monitoring CPU cycles or power consumption used while encrypting or decrypting, like that's crazy that you can use that to break a freaking encryption. Worked on elliptic curves. In Will, it's quite hard. Needs a lot of background work for CS stuff. Oh, nice. Stockno, hey, I'm doing good. I did. I looked at the. I forget what it's called now, but the thing on the Canary Islands, like how they communicate with whistling. I listened to a little like audio thing. That's crazy how they can communicate up to like 5 kilometers. Let me should be in my browsing history, right? Where is it? Where is it? Yesterday. Come on. I also looked at Arrow's theorem. There we go. I found it. Silbo Gomero. So for those who didn't see, yesterday Sakano popped in the stream. I was playing Daisy. We were just kind of like chatting about stuff. This is a version of Spanish that uses whistles, which is kind of crazy. used only out in the Canary Islands. But you can use it to communicate up to 5 kilometers away, which is kind of amazing. This is more of an interesting thing. There's a actual like actually I can play it. There's a little recording of what it sounds like there too. Ooh, I hope it's not too loud. Like I can't even whistle at all to be able to whistle loudly enough to have it like carry 5 kilometers away is kind of amazing. No, Director, we're going on cryptography, more interested in analysis and algebra. Cryptography is a wonderful hobby for you. When you first learned discrete logarithm problem, you were puzzled. I never heard a discrete logarithm puzzle. But yeah, the cryptography is a really interesting application of math. Me when I see a sexy girl on the streets. Yeah, and if you're one of the people who lives on the Canary Islands, you could cat call from 5 kilometers away underscore. That's a level of cat calling that most people just cannot achieve. Diffie-Hellman key exchange method. This I might have heard of this. You do math and thus never go out. Same. You can exchange your key basically using discrete logarithm problem without giving any certain information. Really? That's kind of awesome, Mert. Perp. I wonder what it's like with Canary Islands when they sext. Hope you're doing well, Perp. Yeah, Jesu. Underscore is just memeing. Depends on the complexity of finding a power of a cyclic group with generator G. Ooh, that's a fancy. That's like a neat connection. I can see why groups would come up though with the modular arithmetic. On the inside just a little bit as always. Can't complain. Fair enough. They're definitely going to talk about their husbands and wives in those ways. Yes, talking off, I looked at the basics of arrows and possibility theorem. If you wanted to talk about it in some way, let me know. Or I don't know if you have a specific thing that you wanted to talk about it, but this is what this is what I was looking at last night. This is more of like a philosophy thing. But it's kind of interesting where it's saying with some caveats, or like if some assumptions are met, it's not possible to have a system of tallying votes that respects every individual's opinion in every scenario. Which is, it's always kind of an interesting thing to prove that something's like not possible. But it seems like the example that this article uses is basically a tie, which isn't, I don't know, to me that's not like super revolutionary, but, or that the fact that you can have a tie as a result of a vote, but it's interesting that like we can put actual assumptions to when that could happen. The theorem that proves democracy sucks. Yeah. Basically, that is one way that you could interpret it. Uh, yeah. There are some who take Arrow's theorem to show that democracy conceived of governed by the will of the people as an incoherent illusion, which I think is a little too far, but take course related to democracy and Arrow's theorem from a mathematical perspective. Really, Mert? That sounds like a fascinating class. A mathematical perspective on democracy and Arrow's theorem. Just put me in charge instead, Jasu says. Democratic anarchism doesn't work. The individual, the voter, cannot work. Popular vote is the best system from their findings. Jasu for president? Yeah. Yeah, it seems kind of impossible to always respect everyone's. Well, what am I trying to say? I guess my thing is that just because a failure is theoretically possible doesn't mean it has to be a bad system. It's going to be very rare that it actually happens in reality. Like this example just has 3 people in it. But when you have like, tens of thousands up to millions and billions of people, it's a lot less likely. And if one does happen, you can make rules for like a revote or something like that. And yeah, it's always going to be impossible to respect everyone's preferences like it in this scenario, I guess. Well, I got its democracy, this facade of democracy to the face of the corporation of the USA. Yeah. Yeah, so it's pretty interesting, like theorem. Like I would have never thought that you could actually like prove this. They list the assumptions you have to make somewhere. Where is it? Region of compromise into Arrow's theorem. I think Arrow's compromise among the voters or among the policies that they're voting on. I think that Arrow's theorem kind of would come after you've already tried compromise. Like it's very late in the process. I don't know though. If x and y are 2 sets, x prime denotes the complement of x, then x intersection x union y prime. Hey Dev. I'm happy to keep on talking about this type of stuff, but let me bring up Ansh's question and put it on the screen here. X intersect X union, oops, union nothing, union Y prime equals what? The law goes amongst the government fund a government net for voting. They don't want to do that though, neither party, because it would completely clear up all the obscurity of our voting system. Yeah. That's there's always like I don't know, just the some forces want to make voting easier, some want to make it harder. It was very interesting to like, because I had always heard that like ranked choice is a lot better than at least what we have currently in America with just whoever gets the most votes wins. But there's an impossibility theorem seems to like poke a hole also in like the ranked choice idea too. Do you know image where the same solid casts a disk shadow on one wall, casts a square shadow on another wall? Really? I don't think I have seen that image. The American political bipartisanism would cast squares on both walls. I feel like it's a deeper joke that I'm not completely understanding. But if you're saying that America has issues, I'm definitely going to agree with you. Among voters choose a candidate like if there's some sort of equation to teach each of the premises, it would then show a better outcome. Compromise among voters choosing a candidate, like if there's some sort of equation to each of the premises, show a better outcome rather than Duncan's theorem. Like that's another can of worms. I haven't heard of Duncan's theorem. But yeah, I assume Arrow's theorem means, or kind of assumes that the voters are already settled on their points of view. But you could kind of, I guess you could probably use it to like inform some kind of a like ongoing process, I guess. Yeah, I mean, there's always flaws no matter what the medium is for voting. CGP Grade did a great video on that. Oh, like ranked choice voting, Jed? Um, that could be cool. All right, so Ansh, I'd start with working on this bit here because there's more to do here. If you know De Morgan's law, I believe it's going to say x union y complement. I think is x complement intersect y complement. Yeah, okay. I'm just mentally proving that in my head with like the Venn diagram proof, basically. Um, so let's apply that here. So x intersect. Now this bit becomes x prime intersect y prime. Yeah, coercion does feel like a separate thing. I don't know. And then we do end up with an x intersect x here. So I believe this is all associative, you would say. So like, it doesn't matter if you do this first or if you do this first. Like you can make the parentheses however you want. And so if we do choose to do this first, which we're allowed to do, x intersect x complement is always empty. So you might denote that in different ways. I think the most common symbol is like that for empty set. Um, and then empty set intersect any set is just going to be the empty set. So I think we just end up with empty set. And I think that kind of makes sense because we started with x intersecting more or less an x complement. So something crazy would have to happen inside here for us to not get the empty set, I would think. I mean, does that make sense though, Ansh? Voting systems are like capitalism, fundamental assumption of agents being fully rational is more than a bad hypothesis. That's true too, underscore, yeah. But yeah, I guess the issue with real life is that you always have to choose some lane. And I feel like people see once you do choose something, people only look at the downsides of that thing and say this thing sucks. We need something else. But once you choose something else, there's people are going to say do the exact same thing with that alternative. It's kind of like I don't know. I feel like there's never winning. Yeah, sure. We could do this the Venn diagrams way, or Venn diagram way. Um, I don't like Jesse. At least in America, we can do our taxes completely online, and that's another pretty important like government function. It is a bit of a different thing because uh, the IRS people who collect the taxes already have a lot of our data, which isn't necessarily true with voting. But I imagine there's a way to do it where it's still pretty secure. I don't really like know that though. X, Y. Okay, so if we do it the Venn diagram way, um, let's start from the inside of the parentheses and work our way outside. So X union Y is everything that X and Y covers put together. So it's that. But then we complement it. So we actually want everything that is not covered by X and Y. So that's X union Y complement. And then in blue, X is just X there. And so their intersection is indeed empty. Like there's no overlap between the blue and the green here. So that's a visual way. I don't know if this counts as an actual proof or not. I guess I don't see why not. But this is kind of a visual way of seeing this. Dev, yeah, sure. Oops, I shouldn't have, I shouldn't undo all that. Example, you prevent electoral boards from tampering with it by making it illegal. Yeah, ooh, Dev, all right. Let's see if we can do this. This is definitely a question. It was gonna be motivated to make you pay more or less taxes. They they could want to redirect where your tax refund goes or something like that. I don't know. Ansh, yeah, no worries. Thank you for the question. If it includes that into each premise after its current results, then that would show what that middle point, that mode of democracy, better than the centrist or the moderate choices, the result of the election, because Arrow's and Duncan's theorem kind of passionizes the further extreme of politics because the centrist or moderate is the dictator. So I'm just reading that a few times stuff now, trying to understand it. I mean, I guess that's very much a matter of opinion, but the which I mean this is all opinion, so I don't know why I would say that, but the centrist or moderate is the dictator. If you were to choose one thing to be like the dictator, you have to go with one thing. To me, it would be the centrist or the moderate. That's kind of taking the average of everyone's opinion. it'd be like the most palatable thing to the most people. Oh, nice, Jed. I'm gonna bring that up and give it a little watch after the stream. If people are interested in like videos 2 and 13, okay, nice. If people are interested in like, so like I don't know the best at conversations like this. To be honest, I don't really have them a bunch on my stream, but Ivan Neo is a fantastic streamer who he talks about philosophy and physics, and the philosophy stuff is like this would be like right up his alley. So if you're interested in someone who's actually like pretty knowledgeable about this stuff, I can highly recommend his stream. Um, yeah, I feel like Jasper is arguing some of the specific realities of what Perp is saying. Perp is just kind of making the high level argument of. I feel like Perp and Jasper are arguing about slightly different things here. Like I see what Jesse was saying, where there's always going to be an issue with trying to change the method of voting to something else, but that doesn't mean that we shouldn't try to change or make it easier. We should acknowledge what the downsides are. I don't know, but yeah, I mean, it could also be true that just voting electronically isn't there yet. I don't know. It's not something I have researched. Concept of liquid democracy, interesting too. I don't think I've heard of that one. How do we want to do this? We need to think of what powers, like we want we want to hold it somehow so that these twos that come out to be positive are equal to this two that comes out to be negative. I think the signs are important here. Let me quickly look up what liquid democracy is. Oh, you know what? Also, Shane McInnes has been doing a series of streams. Oh wait, shoot, is there an underscore? I think there's not. Did I get it right? Yes, I did. He streams about history, sociology, that sort of thing, and he has a series of streams about the history of government in particular that are pretty relevant to this type of stuff. Good marks are sort of voluntary. Can be included in decisions and used by default, can opt out by way of abstaining or delegating voting to someone else when they lack time, interest, and expertise. Oh yeah, that is interesting. And I guess that's that's kind of like what happens in a lot of governments where you elect a representative, unless I'm maybe I should read more than 2 sentences about it, but or one sentence, but I don't want to ignore the math question here. Exponential subtraction, Anja's saying to try. Negative term. Oh yeah, okay, Jedi, I like that. So the first thing I want to do is take the log of each side, but the zero posed a problem. Anja's saying exponential subtraction, which I'm not sure what exactly that would mean. It could be a good idea, but I'm not sure. I do like Jed's thought here. You have to convince everyone of anything. Yeah. Oh, is it quadratic? It's nearly quadratic. Or I'm not sure. If it is quadratic, I don't quite see it. Doesn't have any blind faith in the government at all. Yeah, I mean that's why transparency is important. So was calling to the antiderivative of f's difference from the points a and b. Hit her with the definite integral of f from a to b. Well, wait, no, that's not quite right. You're saying take the antiderivative. Wait. Hey, Sage. I'm gonna fix your joke. Well, yeah, I guess there's the B and A thing. But I think it's not the same function f, is it? I think we need like a capital F or something. Take the antiderivative of f's difference. Like you're saying take the antiderivative of f of b minus f of a. You're saying it's equal to the definite integral from a to b of that. Wait, is that right? Oh, that might actually be right. I don't think I've seen this book before. My math exam got pushed back to the 30th. Tutoring is going well. Today's my last day to turn homework and minor quizzes. Oh god. Good luck, Sage. Godspeed. Okay. Then you're saying, okay, yeah, with the capital F, then I like that, yeah. You tell me. Okay, yeah, that's just like the fundamental theorem of calculus. Part 2, right? Coacherus, thank you for the follow. Either way, syntax. Hello. Yeah, the capital F is important there, but indefinite integral is not equal to the antiderivative. True, yeah, because of the constant thing, and well, wait, indefinite integral. Would one have an initial condition? Okay, yeah. What do we do with this though? Or I guess what do we do with this is more the question. The right side is a lot more clear. The left side leaves something to be desired. Um, you move 2 carlos of crap. That's enough for today. All right, $10. About to find the sum of bong added to weed divided by fire. Nice perp. Enjoy. That sounds kind of nice. Difference of squares on the left-hand side? You mean like from there? Is that a perfect square? I don't see it if it is. Dev. Oh, I mean, if you already know the answer to the question, I'd rather you just kind of give the solution then. I'd rather do questions that people are asking for help with. If you're just asking this question for fun, that's kind of not the point of why I'm here. But if you want, like, go ahead and just share your solution now. Let me try to factor. All right, syntax. Take from parentheses using separation, maybe Mert says. I'm not sure where the parentheses where. Take 2 as a common factor. Like, I was thinking we could factor something out of the inside of that and use the log identity, but I don't know if that's what you mean, Chasu. You don't have the vision? If there's an electoral college and Arrow's theorem based on each premise, I think that would work, not gonna lie. Why would an electoral college fix that? I feel like you could still just as well have a tie. I feel like you're kind of shuffling around the same votes. Yeah, Dev. Please just share your solution if you don't mind. Think your cat should be the president? I agree, syntax. I do feel like there's some kind of system of equations you can get out of it, where like this plus this times a half equals this. Or not a system of equations, just one equation. Maybe it is that. I feel like you should be able to logic your way around something like this, like justifying an equation like that. I don't know if this exact thing is right, but that's kind of the best I could think of. Bourbaki. I don't know where you're getting that. That'd be great if that's true. Bourbaki somehow was saying 2 to the 2x squared minus 2 to the x plus 15 squared 0. I don't know where this would come from, though. Oh, it's on the whole left-hand side. Oh my god! Well, that's a crazy log identity, Jasu. Oh no, okay, never mind. I see where that comes from. So wait, is Bourbaki a Chad who just figured out the problem? That's crazy. It definitely checks out for that term and that term. I need to do this multiplication out. I need to actually see it. Wow, that checks out. That's a crazy spot, Borbaki. Nice. Now we can just square root each side. And then use Jed's idea of adding this to their side and taking the log. This feels factorable. We want a -3 here and a +5 there. Yeah. And we should probably check these manually, just to be sure. I don't think we would have lost out on any solutions in any of our steps. So I think these should both just be right, but just be safe. 2 to the 36 minus 2 to the 18, 21, 37. Uh, 36. Nice. Okay, x equals 3 works. Um, 25. Okay, yeah. They both work. Nicely done, Borbaki. Once the quadratic, you read the sum as minus b over a. So 1/2. Oh, for factoring that? Or I don't know what you do with that underscore. Okay, I see Goblin in the math discussion posted a question, but I think that was posted before and I didn't know how to do it. Okay, it looks like Dev, I'm looking at your solution. Oh, sum. Ah, I misread it. Okay, so this is doing extra work to actually factor it. You can just know that the sum of the roots is minus b over a. So I have... That's a nice shortcut. Nice. Yeah, underscore. As soon as the log thing didn't pan out, I guess I should have looked for stuff like this. That definitely was tricky to see. Yeah, Goblin, I think I saw you post that earlier, and I'm not sure I know how to do that. So yeah, I'm sorry, but someone might get back to you with their thoughts, but I'm not trying to do it for myself. Just in your previous year, yeah, that's a really tricky question. Ansh, you cannot pay me to do the integral of root tangent plus root cotangent. Yeah, Bourbaki, that's the one. Uh, the question is from Goblin in the Discord in math discussion. It's right there. Yeah, so Bourbaki has a solution apparently. If you want to share it, please do. Meantime, I'm going to go back to doing some linear algebra setting until there's another question that pops up. There's a call Bourbaki. They obviously have the solution. I haven't heard of Bourbaki, the mathematician. So someone else made a joke about it. Oh, it's a group of people. Wait, it's the Nicolas Bourbaki is the collective pseudonym of a group of French mathematicians, or mathematicians, most of whom are French. Hmm. Neat. Who was in it? Coulomb. I see. I recognize that name. Erisman sounds familiar. Mandelbrot. I've heard the name. I think it's everyone that I've heard of though. Weil. Yeah. I see. Maybe I've heard that name. I don't know anything about it though. Take the first term as the nth Fibonacci term and minus n minus 1th Fibonacci term starting from 1. It did look Fibonacci-ish to me, but I still wasn't sure what to do with that. And at some point, I promise I'm going to get the YouTube chat up in that window too. I just keep being too lazy to actually look for something that will do that for me. Rothendiek was in there. I've heard he's had a pretty crazy life, or had. I don't know if he's dead or alive. Sorry for the siren. The cops are onto me. Yeah, I haven't looked at the details of his life, but I think he is he the one who solved one of the Millennium problems and then like became a hermit and renounced math or something? Okay, I think the idea for 16a is that for any arbitrary basis, you can transform it to the standard basis. And then from the standard basis, transform it to the basis you're interested in. Half fish ladies like mermaids? Oh, because of Spanish whistling. Yeah, sirens. Exactly that underscore. My Spanish whistling brings all the sirens to the yard. Um the hermit story was Perelman? Oh, okay. Hermit. That's how you know that underscore likes math. Hermit instead of hermit. Or maybe the French word for hermit, it looks like hermit too. I don't know. Um yeah, the Hermit story. The Hermetian story. Um okay. And now I have to actually try it for B. This type of thing I've been wanting to relearn ever since I started relearning linear algebra, and it's at the very end. Okay, so we need to convert 2, 5, and 1, 3. Or like, wait. So are we doing like any vector with this basis gets converted to a vector in this basis? So we do 2, 5, 1, 3. I mean, couldn't we just do this directly though? Or actually, I guess we have a formula. They want me to do m times n. And then you'd have some like vector x there that you're actually converting. So m is going to be the result 1, 1, 0, 2. N is going to be the thing we start with inverted. So let's get that. 6 minus 5. Okay, so they're at least nice and give us a determinant 1 matrix to make it a little bit easier to invert. Oh wait, yeah, we already used this matrix, right? If I want to sleep underscore, no worries. Thanks for hanging out. Hope you sleep well. And I'll see you another time, I'm sure. And now we just do this multiplication. 3 minus 10 is minus 7. Minus 1. 3. Right. All right, I want to check the answer on this one. It didn't explain it. I got it right, though. Okay, you know what? Both these questions look interesting. Does 19 look interesting? Probably, yeah. Let's start with 17, though. Keep the same base expression in a different order. Change of base matrix B is a permutation. I don't have enough room to write it there. Keep this base vector in order, but change their links. B is a diagonal. Welcome back. Unlurking is fun. It's like it's like a dolphin just like periodically leaping up from the ocean. Positive diagonal. Yeah, I guess that's fair enough. I should have written positive. Yeah, Fembox, I'll go a step farther than you and say that I hate the writing style. You don't have to write a textbook like it's a freaking academic paper. always using that very impersonal language, like this thing is clear now. Um, but I did look through the problems, and they at least did seem pretty interesting, at least. Yeah, so that's really the only reason why I'm using that book is that it's not confirmed, but that's the book they used in previous semesters. And so it's likely to be used again. I might be able to find out now. I think they might have firmed up what the classes look like by now. The other reason that it is somewhat appealing is that it gets to the point pretty quickly. Like we only need to go through the first 4 chapters, I think, for me to feel comfortable. Uh, whereas with like the Needham book, Visual Complex Analysis, I would have had to read so many pages to get to the good stuff. It's just I love the attitude of the book, but it's just way too long for what I'm trying to do this summer. So okay, my brain trying to figure out something better than the 2 theorems. If you can do it, Sock, now you should write a paper. Follow me, Pencer's class. Yeah. I don't think I ever got around to doing the final, but I was definitely following along with it. A few things at the very end, like the Mobius transform, I didn't quite put as much time into understanding as I should have. But I did like watch all the videos and try a fair amount of the problems myself. Okay, so this is hard to think about. For number 18. We have our standard basis vectors. 1, 0. 0, 1. We take them and we rotate them. Let me do an angle like that. This isn't quite to scale. Let me do it slightly more to scale. uh, and we get some new, I guess. We get that. We get that. As you think about Lorentz transformations, I don't think I've ever learned Lorentz transformations. Draw an analytic geometry version of it. So it's because of that. Finding general rotation matrix is more easy. Yeah, like I've seen finding the rotation matrix with this picture way. I think this question has to undo it, which is a little bit confusing. How can we do this? Oh, sorry. Yeah, you're right. I was thinking of Laurent's series for some reason. Duh. Lorentz transformations. Yes, I think it was chapter 4 even. Maybe they also introduced from chapter 3. This question is, oh yeah, true, because we deal with rotations there. Thankfully, this is a hyperbolic rotation. Honestly, I'm thinking of this algebraically right now. Like, I assume A and B are, like, these can be cosine or sine theta, and what trig functions would give us the things that we want there. If I just focus only on the first line, if I let A be cosine theta and B be minus sine theta, that would give me the Pythagorean identity, but then would it work for the first or the second line? Oh, I think it would. Yeah, syntax. It's a pretty cool matrix, to be honest. Okay, well, I just solved for A and B by guessing and checking. What does this mean, though? Like, how do we do this geometrically? Discover yourself an accident too? Nice. It's really helpful. Then we change it to Senshin Kosh. It's the matrix for Lorentz. I I don't think I could tell you. I have no clue. Okay, I guess geometrically what's happening, this vector needs to get flipped around and reversed. It needs to put its thing down, flip it, and reverse it. So it's going to look like that. Well, it's a little bit too long. Uh, so we definitely need a negative sign, and then we need the y components to cancel. They need to. That's a weird way to think about it. I don't know. I don't know the geometric way of doing this. Hey, color cone. The algebra way, it works, but I feel like I'm missing out on some meaning here. Bourbaki is saying it'll be Q inverse 1, 0 transpose equals AB transpose. Lubert is saying replace theta by minus theta in Q to rotate. Oh. Just rotate it the other way. I like that. Does it come out to be the inverse? It should, right? That just makes sense. Oh, that comes out, that's the inverse. Oh, I love that works. If you just insert minus theta into this matrix, it's the same as taking the inverse. Uh, because we use even and odd identities here. Thank you, Bluebird. That's the type of realization I was looking for there. Cosine theta and minus sine theta. And that's basically what Bourbaki was saying too. The negative phase gene say, yeah, I really like it. This song is singing it in it. What the hell? I do believe that Arrow's law affects rated voting, not only ranked choice voting, because technically each favorability status and rated systems reorganized by percentage. I never heard of a rated voting. Is that where people like score each proposal? If that's what it is, I assume it would affect that. Error theorem would cover rated voting. A score each candidate. Okay. Yeah, I mean that seems like it would be for my little bit of understanding. The inverse rotation matrix is also the transpose. Oh, is it skew symmetric? Yeah, okay, yeah, true. Indeterminate one, importantly. Nice. Any matrix that preserves the norm or equivalently the scalar product has its inverse matrix given by the transpose. Wait, let me think about that. Any matrix that preserves the norm or equivalently the scalar product has its inverse matrix given by its transpose. So any matrix that doesn't rescale vectors has the inverse matrix given by the transpose. Like it preserves lengths, the length. Well, huh. Is that what the determinant measures then? Or is that what you could interpret it as? If the determinant is 1, it doesn't rescale? Rotation, reflection, right? But I'm thinking like, oh, I guess yeah, I was thinking in general about like orthonormal matrices. But yeah, I don't have an example off the top of my head, but well, I guess like 1 1 1 minus 1. Actually, no, that's not scaled right. Determinant 1 means volume squared, not length. Oh, fair. Um I would need some root 2's for this to have a property, right? Uh, why am I feeling stupid? What am I trying to do? I guess just take the inverse and check that it matches the transpose. But this won't quite work, will it? Wouldn't the minus sign have to be up there? Maybe not. Um, let's just do it. Um, just multiply it by the transpose. Oh, yeah, that's faster. Uh, this is. Well, one might say this is too many root twos. No one man should have this many root twos. Okay, that times that. 1. That times that. 0. That times that. 0. That times that. 1. Okay, nice. Yeah, I could have factored them all out and saved them for the end. What? And so if I did, the other thing I wanted to check was if I didn't normalize the columns. This wouldn't quite be, it would be a diagonal matrix, but not identity, I think. Yeah, 2, 0, 0, 2. Okay, yeah. Okay, nice. Hey, Suna. I waited for you to ask. It's going good. How's it going for you? Been doing some linear algebra studying. Before we had some funky. Yeah, it's linear algebra day. Where is it? We had someone asked a set theory question, and then this funky equation with powers of 2. That actually is a crazy way of factoring it. We did that. Yeah, right. $10. Um, Most unpredictable question, yeah. Yeah, so oops, didn't mean to do that. If we're doing it your way, we'd have a factor 1 over root 2 out front there, and we'd have another one from that matrix out here. And so that would fix it and make it like that. I just wanted to test it without the root 2's and see what we get. I remember the lectures that explained this in a little bit of a funky way. Um, I, I think Strang asked the question, what types of matrices have their inverse equal to their transpose? Or something like that. But you kind of divide up into a few different types in some way. This is a nice way of thinking about it. Okay, what's up with number 19? One, four, five. Uh, this shouldn't be that hard. Just invert B, multiply it by 1, 0. Five, 1, minus 1, minus 4. Wait, determinant of this is still 1. Okay. We get 5 minus 4. And does that check out here? 5 minus 4 is 1. 20. Nice. Okay, yeah. Are the new coordinates of 1, 0 related to B or B inverse? Well, it's the first column of B inverse. It's a terrible B. What does that mean? Setting matrices that preserve the scalar products are called orthogonal. A special relativity also have a set of matrices that preserve proper time. A Minkowski metric. Those are the linear Lorentz transformations. Right. They've introduced us to one of those matrices, but I think they've alluded to there being more. The matrix that we've met, I think, is that one. I think that is analog to orthogonal matrices. I mean, are these not also just orthogonal? Matrices that preserve the scalar product. Oh wait, so I guess when you're saying preserving the scalar product, that means if I have A dot B, it's going to equal the same thing in, or like the inner product. It'll equal the same thing in the normal basis, or sorry, the result of the dot product is the same no matter if the matrix is multiplied with by it or not. That's what it means to preserve the dot product. So I hope. Preserve the Minkowski metric, which is like a scalar product. Oh, true. It's not quite the scalar product. Fair. Okay. Interesting. That feels like a very important concept. I feel like it's gonna need to like sink in as I like encounter it more. I don't know if there's much more meaning to extract from 19. First, I guess I could look at the solution key. First column of M versus the coordinates of 1, 0, and that basis. Oh, yeah, sure. You've heard they say this a couple times now, but don't know what to do. I felt like that. I'm not doing that. The integral square root of tangent and the integral square root of cotangent are both terrible integrals on their own. It has to do with a change of basis for vectors. It's an important but funky concept in linear algebra. Sakana says, I personally think that popular vote retains the best system rather than electoral college. But if electoral college would be on those other theorems, I think it could work because there's a regulation system, but why do a clunky regulation system like that? Regulatory agency simply just not ignoring people's single ballots. Yeah, no, and so for people who are just like uh coming in late to the stream, I've been talking to Sock now, and was interested throughout the stream about Arrow's impossibility theorem, which has to do with like the theoretical impossibility of a voting system that captures everyone's preferences in every scenario if certain assumptions are met. So that seems random. That's the context. uh yeah, no, electoral colleges feel like an abstraction without too much gain. Or it feels like electoral colleges kind of, if anything, remove people's individual preferences. It's moving in the wrong direction in my mind. Kim does not agree with what's always met the 100% majority. That's true, Suna. It's a very efficient voting system. Easy to count. quick to do. I don't know. I guess put another way, in a tool called just a different way of counting votes. You can just aggregate them, assuming the electors have to vote the way that their constituents vote. I guess. Um, but I guess that will be a way of assuring you don't get an undecidable situation. I guess most democratic systems would work better with more voters. Oh yeah, that's a it's like a generally true thing. I think that the more people actually participate in a democracy, the better it works. Um, yeah, I guess the question is kind of like about making a system of voting that respects everyone's preferences, and how that probably isn't possible in every case. Yes and no. As far as I know, I agree with that. um, the world sounds a bit like heaven. Yeah. Yeah, that's always the catch. What's up with 26? Isn't uh eigenvectors of the matrix T? Isn't this just the eigenvalues? If you're working in a base of the eigenvectors, yeah. Okay. Let's check that though. Okay, I got it right. Diagonal. I haven't seen that notation for diagonal matrix, but I guess it makes sense. Um, playlist. Yeah. That's funny. You're not the only person who asked for the link. Um, chill wave slash dream wave. That's the playlist there. It's one of my two like main playlists that I tend to use a lot. Can wait for my first album. Wonder how it's called. Hmm. It's a good question. I feel like I'd want to name my albums after funny sounding math theorems. That's where my mind is going. Like from Stuki's stream, I just learned about Hardy Littlewood circle method. Or something like that. Yeah, but even then, like the method part is important. Hardy Littlewood is a hilarious combination of names, and the album art would be something involving the circles or whatever the hell this thing deals with. I want to make some puns like that, I guess, or like I don't know. I think I want to use my platform to preach the good word of funny sounding math names. Um, I think that Arrow's theorem applies in the States when it comes to party primaries. It works differently by different parties. That's the issue. I think maybe for like Republicans, yes, but Democrats, no. I want to say, but I'm not exactly sure. I don't know exactly how their primaries work. You hear around like that, I'm sure. Yeah. Hmm. I was trying to get a little linear algebra doubt, I think. Should I switch gears to different subject? Hey, study with AD. Welcome in. Oh, Aditya. Okay. Um, there was a general relativity problem that I skipped over that could be cool to do outside of the reading group. Number two, I think. I don't think we did two as a group. This is probably not time. Let me check that. Yeah, we skipped it. So maybe now's a good time to try out problem two. Aditya, I'm sorry, I don't know. I don't really know JE stuff at all. I'm not the best person to explain that stuff. I'm from America. One plus one, that's two. That's a math question I can definitely handle. 4.18. No, Aditya, I'm not gonna send you money. I'm not gonna integrate root tangent. Raj, I don't really know engineering. I'm sorry. X squared equals 2 to the x. So, Rob, I feel like you're just asking annoyingly difficult questions. That's not really what I'm here for. Aditya, I'm currently just doing some studying on a book about general relativity. This is a chapter just on special relativity. Um, so I'm working on this question that's up on the screen now. So Rob, I'm here for homework help. I don't just want challenge questions. If someone has an actual question needs something explained to them, I'll help them. But I think you're just asking me very difficult questions that I'd rather just not work on. Hey Storm, how's it going? This is a question from the General Relativity book, but this one is pretty mathy. Uh, this is I don't know how to describe this. We're talking about four vectors. Uh, and I don't know what the right terminology is to describe this. But I'm working with or we're learning about this like metric, or if that's even what you call it, for space time. And we're trying to prove that in this space, or whatever, this formula for dot products. Minkowski metric, yeah. So Rob, good luck with JE. I don't have an Instagram, Adia. That's not one for the stream anyway. I don't know. How do we even begin to prove this? What's the problem? I mean, well, I don't know if you mean like Or like the problem is to prove this. If you're asking what my problem is, I don't even know where to start right now. Um, how do we prove the regular formula in the first place? I don't even know. I must know where that comes from. I don't know. I can't remember where exactly it does though. Hey Kuzaima, I remember you. Cauchy-Schwarz inequality and cosine theorem, where it says. Really? I thought there was like a geometric way of proving that. Law of cosines can give the regular dot product. Okay, let's go down that route, I guess. Let's understand the proof for the regular dot product formula. Version of Cauchy-Schwarz for time-like vector. Okay. Hey, MMD. Um, so uh, uh what's on the left-hand side? You're going to sleep, Storm? All right. Thank you for saying hi. See you around. Is this a B minus A? Okay. So I was right about this, but it's better to write it with dots. It's probably better to do all this with dots rather than the magnitude. So we want to isolate this, is how it seems to me. The dot product is distributive, right? So we can say B dot B plus B dot minus A. Actually, the minus sign can come out front. Scalar multiples commute. The last term on the right side just says 1A and 1B. But that's not the that's not the law of cosines, right? Like whatever this thing is, this first one also has to be, and same with that and that. Isn't it? Well, yeah, but if the length of one side of the triangle is the magnitude of A. Oh, I need a square root. Is that what you're saying? That I think now I'm better. But the length of one side of the triangle is the magnitude of A square root. The length of the other side is magnitude of B. Jasu, I'm doing a general relativity problem, but I'm starting by trying to prove for regular vectors that A dot B is AB cosine theta. And then we're going to move on and try and do it for time like 4 vectors. But yeah, we're starting with just proving that A dot B is AB cosine theta. That's what we're doing immediately. In polar, we're not doing this in any coordinates right now. Do polar make it easier in some way? Has he proved it to your students? Fizzbuzz, thank you so much for the raid. Welcome in, everyone. Raid message, hell yeah. That's a great raid message. I hope your stream was good. Bernie's here on my end. Check out Fizzbuzz, awesome dude, great at math and physics. Normal streams about computer sciencey things. For news new from Fizzbuzz's end, I'm Don. I do math questions that people have, and when there aren't questions from chat, I pull things to study from that I find interesting. Thank you for the follow, H.O. Burn. So right now we're I've been trying to get into general relativity as a thing that I've been studying. So I haven't actually gone into any real general relativity yet. I'm just in special relativity land so far. But the question we're currently working on, I'm just trying to prove for regular normal vectors that A dot B is AB cosine theta. And that's the warm-up for proving in special relativity that for two time-like 4 vectors, that A dot B is minus AB cosh theta. So that's what we're currently thinking about. Someone's saying that I almost just a matter of canceling things both sides. I think so. That's the sense I was getting to. Hey, Papadoria. Doing well. Nice. Team bit of progress, still net progress. Nice, nice. Yeah, and Jess, I'm interested in seeing your way of doing it too. I would like to look at that also. But I think that This is written in a little bit janky of a way, but I think this works. Like, I don't like having square roots of dot products floating around, but it's technically correct. Jess is saying an alternative approach where we do things in polar coordinates. Wait. X1 is R1 cosine alpha. Y1 is R1 sine alpha. Oh, this is for the same vector. Okay, so then let's say like vector A then is R1 cosine alpha, R1 sine alpha. And then like B could be the same thing. Let's try this. I'm interested to see. Papadoria, right now we're talking about how to prove that A dot B is AB cosine theta. This is a warm-up for doing special relativity time-like 4 vectors. We're working up to proving this, that A dot B for 4 vectors of special relativity is minus AB cos theta, but that's going to come in a minute. Yeah, this is an interesting way of thinking about it, Jasu. So we're going to get R1, R2, cosine alpha, cosine beta. Plus R1, R2, sine alpha, sine beta. This looks like cosine alpha plus beta. Alpha minus beta. Ah, that's exactly what we want. Oh, this is a... Oh, man. I like... This is really succinct. I like this, Jasu. Thank you for... For saying that. Jasmine, what does A dot B actually mean? That's a good question. Naman, you say for arrows? Oh, well, thank you. A dot B, that's always a hard question to ask. It basically... It doesn't have a direct geometric interpretation, or at least it doesn't have that clean of one, but the best way to interpret this geometrically... Yeah, it is. It's kind of hard to answer, but like the best way to interpret it is that it measures how in line things are. Cosine of 0, if they're perfectly in line, is 1, and cosine of 90 degrees, if they're out of line as much as possible, is 0. So this cosine kind of serves to scale the result. So for the same length of vectors, if they're pointing the same way, the dot product is the highest. And if they're pointing exactly perpendicular, the dot product is 0. But it's hard to say that much more than that about physically what it means. But I just tutor math. DP over for the hour mark. I mean, I'm impressed by the length of your streams normally, BizBuzz. You easily just pull out like an 8-hour stream. Grace, it looks easy. I tend to get limited by my voice, but also I also just get tired the more math I do, I guess. If we welcome in, it was the convenient fact that A dot B can be computed in a couple additions of multiplications rather than calling a trig function. True, yeah, yeah. Sometimes you can see it as a projection, Tamwheel says. Welcome in. Yeah, it's involved in, yeah, because like you can project like the projection form is like a dot b over a dot a if you're doing one vector onto another or something like that. Oh, I have this slightly wrong. Wait, I think it's just this. A dot B, yeah, that's how you project B onto A. I might have the order flipped. But yeah, these are definitely involved in projections, yeah. Non-dairy neutrino, hey, welcome in. It's going good. How about you? What level of math do I teach? I'm best with things that are like calculus and below. I can do some things like linear algebra, differential equations, things that are a little bit beyond calculus, but after that it starts to get a little bit sketchy. And for anyone who's new, I do dual stream to Twitch and YouTube. I'm working on getting the YouTube chat up there too, but I've been a little bit too lazy. So if you're talking to someone who's not there in the chat that you're looking at, that's why. Can you say that it's like adding vector A in the magnitude of B in the direction of A? I think in a sense, yeah, Jed. And that's getting back to the projection idea. Getting caught up on grading for my series class. Nice, nice. No group theory / combinatorics. I am terrible with both of those things, Yipweed. But there's people around here like Jasu who are enthusiastic about those. For anyone who doesn't know, there's a whole little niche of people who stream math help. There's a whole list of them, plus Academy of Useless Ideas. It's like Ian Stuckey in that list is another person to be enthusiastic about group theory and combinatorics. Najaf, I have never had to take the JE myself, so I don't have tips for you. I'm sorry. You used to this back when you were in high school. College math is different and wild. Yeah, Naman. The year of math on Twitch. Yeah, Fizzbuzz. It's really come a long way in terms of like how much people are talking to each other in the community that's kind of been built up. Okay. I hope I'm caught up with chat. If I missed someone's chat, that wasn't intentional. Oh wait. RCN. I did miss your chat. If I said magnitude direction, you can maybe see the dot product is a product of the dot product is a product of the magnitudes R1, R2, and product of the directions. Right. I think that's what Jasu was getting at with this polar interpretation. That's a nice way of like summarizing it though. Is possible to learn high level math without a teacher? Yeah, but it's a little bit harder. You can definitely self study stuff though. Okay. Now comes the scary part of this question, which is proving it for time-like 4 vectors. Combinatorics fan? No, I am not a combinatorics fan. I'm very terrible with combinatorics. You smelled special relativity. Yeah, this is the thing on Saturdays. We've been having meetings on Gravity by James Hartle, and I just pulled a problem out of that book now to do some studying with. Do some physical engineering on these nuts, if you know what I mean. Perp. This is the place where we appreciate these nuts jokes. I, I love people like they keep coming up with new these nuts jokes also. Like I just heard like, hey, do you see that wire? And they're like, what wire? And you're like, why are these nuts in your mouth? It's like, man, it's been years and like just completely new one. Gotta spice it up a little bit. Everyone here is all smart. You are just Blaze. Hell yeah, dude. Why don't I enjoy combinatorics? It's so picky. That's why I don't enjoy combinatorics. It's so easy to make a small mistake based on the wording of the question. Isn't there a show called These Nuts? I never heard of it. Or am I about to get These Nuts? Who would watch a show called These Nuts? Bert Hartle being used more and more in the undergrad relativity because it's in GR. Tailoring of space-time physics is okay. Yeah, this was recommended by Dr. Cook, who has streamed a few times himself, but he's a physics professor and he seems to really love the book. So far it's just been okay as someone who's been learning this for the first time. The people asking about combinatorics are over on YouTube. I dual stream and I keep meaning to get the YouTube chat listed up there too. I just haven't yet. The combinatorics people, yeah, they're on the dark side. Jive, very much that's like that was for advanced questions. If you're talking about JE advanced, I normally can't do those questions. They're a little bit too difficult. We're not on the dark side. The chat on screen is the Twitch chat, Jai. I stream to both twitch.tv and YouTube at the same time. You prefer planters? People seem to really like Deets nuts. Is that an actual brand of nuts? Oh my god, premium deli meats, cheeses, and sausages? Oh my god. Oh my... They're meat bites. Wow, that's perfect. I too have premium meats. Yeah, the premiumist of meats. It's a band called These Nuts? That doesn't surprise me. Mr. Purely Bubble with no possible alternative interpretation. It's not a family friendly stream. You can say dicks, tits, fuck. All those fun words. Some weak ass protein content, Han Yolo. Oh, I didn't even see. 16 grams of protein in 56 grams? That's a pretty high. Well, I guess not. 16 over 56. That's definitely a number, I can tell you that much. 30 something? Why is Wolfram Alpha going so slow? It is the original smoked sausage. Could be meatballs. See Papadoria's put a question in the YouTube chat. Hey, Sahil. The Gojira poster? Yeah. Gojira is awesome. Okay, you know Wolfram Alpha's having a bad day when it can't do 16 divided by 56. Okay, fine. I've lost interest, Wolfram. Okay, wait. Let me read Papadoria's chat over on the YouTube side. What's your classes for the year with my professor? We decided to do the next 3 classes about specifically Fibonacci numbers, properties, formulas. I had a problem with that related to Fibonacci numbers and trig. Can I send it? Yeah, sure, Papadoria. There's just a study problem, so I can hop right over to your problem. About to close YouTube in this stream. Thank you, Jay. NIT tag? I don't know what that means, PD. Yeah, there's also a lot of trolls on YouTube who say very strange things. So if I did show both chats up there, I would need to put a pretty big delay on it. Because YouTube gets kind of wild. Okay, now I need to get caught up with the Twitch chat. Dude, people are popping. I was gonna have variable chat, dude, was variable weights. 4 over 9% protein. Tits are just the female equivalent of inbuilt stress balls. Now, at first, I skipped over the stress parts. I thought they were just going to say they're the female equivalent of balls. And I was like, I don't think that's true. But yeah, stress balls, sure. 2 over 7. L'Enfant Sauvage. Oh, yeah. Gojira. The Flying Whales album was my favorite. And they math in like 6 months? Oh, that's crazy. You're going to be rusty. Really colored red for the blood on their hands. Okay, Papador is starting to put his question up. Oh, God. Now, Papadoria is known for having very difficult questions. I don't know what kind of class he's in, but it's not an easy class. Arc cotangent. These are Fibonacci numbers. You want to see the crazy shit they say on the dark side? I know. There was one day where there was a flood of different people. I assume it was like a bot thing, or I don't know. They had some accounts prepared, but people came flooding in saying that they were told I was going to eat a poop sandwich. That... and there's just like at least 10 different people who all just came flooding in, spamming the same message about telling me to eat a poop sandwich. So yeah, it's stuff like that. You heard about that too, Han Yolo? Were you part of the crowd? Why would this be true? For Fibonacci numbers? Wait, Mouth of Kala, my last creation? I don't know the... Have I not... Maybe I'm not up on my Gojira. It's been a while since I just brought up their Spotify page. Just a card with 10 fake accounts. Induction time, Indian is saying. It's involve alternating numbers. They're on the fonts. Oh... Just I tend to get stuck just in the Flying Whales album. I've listened to their other songs like once, and then I didn't listen to them again. Sharing microbiome improves immune system. Actually, genius idea. This poop sandwich. I literally just read the other day about how if you have problems with your microbiome, they literally make like poop pills, where you take someone else's poop, and that helps your microbiome. I'll have to give it a listen for. Um. So what's the relevant? I mean, do we have any relevant identities with arctan or arccotangent? I feel like we're going to need to know some identities here. Inverse cotangent identities. You don't think the pharmacy sells those? Ugh. Tell me the annoyingly vague inverse trig things. Yes. Go away. Stuff like this. You love coffee? Oh, I love coffee too. Arccotangent, inverse cotangent, Jasu. Hey, Calder Productions. Take cotangents on both sides, it turns into Fibonacci identity proof. Really? Then we need to, I guess we need a difference identity for cotangent. When we came up from HD 650s. Oh, dude, I have HD 600s. It's these right here. Return in the box for the new cable for shipping. Games on refunded for both the cable and the new one. Wow. Nice. A large amount of color born in winter. Oh yeah, born in winter. I know that one does go hard. Headphone twins, yeah. I love these things for music. Do you have like a DAC and an amp too? Where do I put this? The Axis Fire 2? Okay. I feel like you basically just named half the album by now, but I'm just gonna go through the entire album and give it a listen, because I honestly I should be doing that more often. Um, so this we can use 1 over this. A little over a third math man. Since I turned into that. Okay. Let me catch up with where. Oh yeah, sorry, Jesse. Yeah, it's 1 over tangent. I didn't realize that that's what you meant. Um, cause oh, so this is gonna turn into tangent still though. It's not doesn't become cotangent. So we're fourth, trying to be cheeky. Really, I'm just cheeksy. 1 plus 1, 2. Prove the left-hand side is equal to f2n plus 1. Interesting, Papadoria. Um, how do these clean up? Wait. Oh no, I'm ignore me, ignore me. Um, I did this terribly wrong. Wait, but this is Apple adds brain implants? You know, the world was always gonna go that way. I'm gonna go play Counter-Strike. Good luck teaching these nerds. All right, see you, perp. Enjoy your Counter-Strike. So yeah, I did forget the arc cotangents. Does tangent of arc cotangent simplify though? I feel like it should. It oh come on, it has to. There has to be an identity that helps me here. Yes, there is. It's this identity here. I flip the inside and make it tangent. If the inside is positive, which for Fibonacci it is. J advanced? No, I'm sorry. I don't know J advanced. Dot product their head. Yeah. Okay, well, let me delete that. Delete that. Yeah, I've seen many J advanced questions before, Terrence, and they're pretty much all insane, and I don't know how to solve those questions. So I'm sorry, but I'm really not the person to ask. It'll be 1 plus 1 over f2n, 1 over f2n plus 2 over 1 over 2n minus 1 over f2n plus 2. Yeah. So let's get rid of these denominators. f2n, f2n plus 2 plus 1 over f2n plus 2 minus f2n, 2n plus 1. Post the work in the Discord? Okay. I was about to check with where you're at. Or with what you were putting in the chat. Do, 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 do. Don't play bad games. I definitely would agree that I would say CS:GO, but it's CS2 now. I do not enjoy that as a shooter. I don't think it's a good game. I grew up playing Call of Duty though, which maybe influences that. So I think we agree with each other. We got the same thing here. Oh, you're using this is equal to f2n plus 1, is what you're saying? Which would make sense. And you divide it over the other f2n plus 1. Okay. Yeah, I kind of like it on the other side as well. And so I assume we want to strategically substitute one of these. I'm stuck on this step for 4 hours. Okay. Um, well, I'm feeling less optimistic now. But let's try it. F2n is equal to oh, I love Dark Souls. I'm planning to start a Bloodborne playthrough very soon because you can emulate it now. Non-degree neutrinos thing, that's just a quadratic equation when you expand the later indices. I'm from America, Terrence. DS1 these last days? Oh, that's a great I mean I love them all. I started on DS2, so that's my favorite just because of the nostalgia. But Dark Souls 1 and 3 are definitely like probably better put together if I'm being honest. How should I guess I'm trying to figure out how do we expand these indices? It's like the objective is to get to a true statement, like 1 = 1 or something, I guess. Oh, should we think about this instead? Maybe we should think about this seems like it might yield something. Does it though? I don't know. Let's find out. Oh, it really doesn't. Maybe that's not the play. Uh, right, Jasu. We can assume these are positive numbers. That they're Fibonacci numbers. Like technically, it could be zero if it's the very first one, depending on where you start the Fibonacci sequence, because people don't start it at the same place all the time. But I think just it's at most one thing that would have to be thrown out, and I think that's okay. um, I guess I'm back to trying stuff like this. Achinia, I'm sorry, I don't know the JE advanced. Yeah, I'm going for terms of two squares here, for better or for worse. No, I know the JE advanced is a Chinya. I just don't know how to do the questions. And hopefully these are something good and not bad. And it's the difference of squares of consecutive terms. I'm okay at Chinya. I don't want to. Yeah, we might need to property Fibonacci sequences here. What's up? What is the Cassini identity? Oh my god. This is the type of thing that we needed. Probably. Great call, Jay. Jai. Sorry, I'm not sure how best to pronounce that. This seems very helpful. Bruh. Yeah, this looks so similar. Um, from here is what we would want. Uh, So what do I have to... We don't have the exact thing. We have for certain indices. We should make sure we're... What correlates with what here? These are 2 apart. These are 2 apart. This is in between the other 2. This is in between the other 2. Okay. And here, it's always an even n. No, it's always odd n. Perfect. Right. So yeah, as Jai is saying, you could say like r is equal to 2n plus 1. And you would have f r minus 1, f r plus 1 minus f r squared is minus 1. Yeah, it's just always odd. By in Italian, nice. So yeah, I mean, once we've obtained, or like, you know, you wouldn't necessarily have to do even this step. But like, from here, I assume we can hopefully just copy a proof for Cassini's identity. We're having to prove that in number theory? Oh, wow. Ooh. Basically non-dairy neutrino, yeah. Oh, Nuth. I recognize that name. It's a determinant. Ooh. Can I should make this easier to read, right? Large and in charge. It's hopefully a bit easier to read. Why? Okay, I'm showing with going from this to this. Why would that be a thing? There must be some other property they're using here. But there's also proof by induction that doesn't rely on that. I think you could sell doing a proof by induction from here though, Papadoria. And that wouldn't be too cheesy, I think. Oh, is that what it is, Tamwile? Oh wait, can you raise that matrix? Oh, that's what's happening? Does raising this matrix to a power generate Fibonacci numbers? I need to see that. That's kind of awesome. Okay, we got our 2. Oh, it is stretched. Thank you, Papadoria. I don't know why that happens, but it sometimes just gets stretched sometimes. I have not seen this matrix for Fibonacci sequences before. I've seen the eigenvector thing for Fibonacci sequences. Oh, wait. Oh, maybe that's the same thing. I don't know. 2, 2. All right. I mean, I'm starting to believe it. Hey, Japanese physics, I'm not too great with. I'm probably gonna I'm starting to lose my voice here, so probably going to stream for a lot longer. If you want, if it's a short one, I can try it, but it kind of depends on the question. My physics knowledge isn't too great. So you could compute Fibonacci numbers in O log n time. Ooh, that is nice. Okay, but yeah, sure. Then try posting if you want, Japanese. Sounds good. Non-dairy neutrino. Once you see the question, I'll bring it up. I'm starting to like lose my voice, so I'm not gonna be able to take every question that comes in after a certain point. Yeah, public. I probably would. And if you want, you can do the matrix way, but maybe if you're concerned about that being weird, the induction I think is pretty reasonable. But it looks short. I haven't read it that closely. That's crazy. What's a new identity? Hinabu, are we waiting to see Japanese question? Yeah, me neither. But you don't have to even like name it. You could just start to do induction on that without ever naming it too. Monet? Oh god. There's Moda or Monakov or Monak of welcome in. Is it a matrix lesson? It's kind of whatever people ask. We're about to look at one, or we were just looking at some matrices, and then Abhinavu put another matrix question. What is A prime here, Abhinavu? Or like, what's that? Could it be transpose? A joint? Maybe. Transpose? Okay. Nice. Then yeah, we can do this. Okay, in Japanese. I'll put your question up on the screen right now in case someone wants to start looking at it. But this is probably the last two questions of the day, just for the sake of my voice. Abhinavus I can see relatively quickly. So we're starting from this. And so we have a property that if we have two matrices multiplied together, we can split up into two separate determinants that are multiplied. So that'd be my first step. The second step is if you have a scalar multiple. Ooh, does that come out with a power? It does. Let me verify that property. I think it's -1 to the power of 3, technically. I just want to verify that. It's basically this property. Okay, yeah, there we go. That's the exact thing. So I'm going to use this property for the negative sign. So that negative sign is like a -1. It's order 3, so it'll be -1 cubed times determinant of A now. And now this, the determinant of A transpose is the same as the determinant of A. So we can just make that determinant of A Transposing doesn't change it. And now we've gotten these both to be determinant of A, and we know that that's 2. So let's plug things in. -1 cubed is just -1. Determinant of A is 2 times determinant of A is 2. So we get -4. So that's how we do that one. Thank you for the question. Let me know if that made sense. Moment of inertia of a thin rod, mass m, length L, about axis theta angle from one of its end, theta from horizontal. Oh. No worries, Raghav. That's a funky... So if the rod is like that, is the axis is like this? Wow. Okay, this might not be that bad. So it's r squared dm, right? Is this standard with the axis at a tilt like that? I thought it was standard for like perpendicular there and perpendicular there. I guess we can use the perpendicular here to check. How, so I think dm is cosine theta dx? Or wait, no, I'm sorry. Uh, no, it's not orthogonal. That's where this gets weird. Those two are standard. Oh yeah, okay. Um, yeah, Japanese. Any hint you can give? The axis is. I mean, I think it's the same thing as if you had a perpendicular rod here, but you like tilted it so it's at an angle. I have a hard time turning on and back off. Uh, it's gonna rotate. I guess like this end would rotate in a very small circle, and this end would rotate in a very big circle, is what I'm imagining. I don't know if that's right. Waiting for the axis to update before I do. No? Oh, no, this isn't. I'm on Windows. The font is Ubuntu font. I just like Ubuntu font, so I installed it on Windows. Um, Betrayal. Yeah. Bamboozled, hoodwinked, I shall not stand for this. Papadoria is also a Linux user? I agree. Linux is just better. If everyone used Linux, I think things would be a lot easier. But that's not how the world is right now. With cicadas? I don't think we have cicadas. I'm in California. I don't remember ever hearing they're like buzzing or anything. I have a bunch of gnats in my house that are super annoying. Think is the axis perpendicular and the rod tilted. Determinant of dawn is -1. Windows. Gnat, like GNAT. It's a little bug that likes light. Cicada? Cicada. Okay. Thank you, Obi. Theta is still this angle though, right? Yeah. 3301. I don't know what 3301 is. Jai is calling it a third ml squared cosine squared theta. Um, Cicada 3301. Oh, they're puzzles. On 4chan? Huh. Funny. I never heard of those. I think so. Non-dairy neutrino. That's how I'm interpreting this. Nishant, I'm sorry, this is gonna be the last question for the day here. Yeah, shut up my house. Yesterday my mom sent me a picture of the yard. Thousands of shells on the ground? Wow. I bet. Like I can imagine the sound. Cicada. I don't even know how I pronounce it at first. Cicada? How do we measure R? Is R measured perpendicular from the axis, or is it measured perpendicular from the rod? I think from the rod. No, axis. No, wait. I don't know. Those are different distances, though. It matters, right? Measure the booming at around 90 decibels? Oh my god. Oh, all right. See you, Japanese. Uh, the answer is apparently ml squared over 3 sine squared theta. Yeah, I still don't understand what's actually happening here. Could only escape by going inside. Oh my god. If Jabby has already dipped, I might just call it. Well, yeah, so I did see thetas from the horizontal, but it doesn't make sense with Japanese said to draw it like this. So I really don't know. I'm confused about that part, and then I don't know how we measure the distance. Um, yeah, I don't think it make a substantial difference anyway. But I guess this is maybe more like theta from the horizontal. Solve for the case r equals 0 and interpolate. I see we want distance like this. Or sorry, like perpendicular like that. So is r equal to uh uh something? R is definitely equal to something, I can tell you that much. Um then your slices aren't disks. That's true. But they say thin rod. That's why that's something that'd be okay. So like x tan theta, is that what I want? I think so. What would DM be? Cosine theta? I mean, my x-axis is like this is my x-axis. Are you putting the x-axis through the rod? I think we don't have to worry about it. Non-dairy neutrino. I assume not. With respect to the y-axis? What? I don't think it is. Uh, Nishant, I already said this is the last quote question of the day. Sorry. Thank you, $10. But yeah, I'm worried about the DR. That's what I don't know how to get in my, or that's what I don't know how to do here. dr, there's a triangle here. Cosine theta is equal to adjacent dx over hypotenuse dr. I'm going to say lambda is length, or mass over length. This is the constant that we're given. Okay. What does this give me? 0 to L cosine theta x tan theta squared m over L 1 over cosine theta dx. Let's see if this works. If not, I might just give up because I'm not good at this. And I don't have much more voice left. Theta is a constant. Anything with theta can come outside the integral. Tangent is sine over cosine. Oh, it might need to be a sine theta here for some reason. I feel like it should just be tan theta with how I've set this up, though. It's seeming likely that I messed things up here. No, we are at next. It was x squared, so it's x cubed. No, wait, this is right. Oh my god, did I do a thing? ML squared over 3. We get a cosine cubed. One of the cosines cancels with that. The other two cosines cancels with the tan. I did it! Oh my god. There we go. Okay. Jai, I think you're putting the x-axis through the rod. That's why we were getting different results. Or that's why we're doing it different ways, but that's it comes up to the same thing. Okay, so Japanese, I hope that made sense. I need to go. My throat hurts. Okay. Thank you for the question. So yeah, on YouTube, I'm gonna cut the stream off. On Twitch, we'll look for a raid. So yeah, anyways, here on YouTube, thanks for being here. See you later, YouTube.